Justin.
I just saying thank you, Jody and Justin, for all of the great background. I'm going to just continue building off of that. And so I'm going to be presenting some base workflows. I know there's varying levels of expertise here, so you can build on it, pick your favorite Python packages and your favorite editor moving forward. I'm just going to present some workflows using Google Colab. So this is going to allow us to make all of our requests, create different maps, export TIFFs, CSVs, all within our browser. So if you're not familiar with it, Google Colab is a free Jupyter Notebook environment that runs entirely in the cloud. On the left here, you can see kind of what it looks like. They have a lot of great documentation. So they have a welcome to collaboratory notebook here that you can go through, see how to start setting up and see a lot of examples using it. On the right, it shows you when you open Google Colab, it gives you different examples or different areas you can go. So you can look at examples that have already been made. You can look at your recent documents. You can connect to your GitHub or your Google Drive where the notebooks are stored. So just looking further, if you were getting started and you wanted to use the Climate Engine API and you're starting a new notebook, you would go right here on the bottom. It's going to say new notebook. Otherwise, if you had a recent one that you've been working on, you could see I had Climate Engine API examples for today here. You could just click and open that also. And then I have links to the different examples here. So if you have the slide deck, you can just click on them and it should take you to the Google Colab notebooks for these examples. And I kind of want to just give a lay of land, all of the things that are really important moving forward using Google Colab. So we'll work from left to right. First, you see you can add your name script here. And that's how you're going to be able to search it within your Google Drive. Down here is upload files. So for these scripts, I pulled rasters for the entire United States. So I uploaded a shapefile for the US, and it allowed me to use it within the code here. Moving over, we have these little buttons for adding both code snippets, which you can see in the green hashtag add code. Which is going to be Python, and then adding text that allows you to do notation as you go through, create sections that you can go back to. A really great thing here is that all of the changes are saved. So just like working in a Google Doc, you don't have to go file save. It's going to regularly do that for you. And then lastly over here, something that's really great about Google Colab is your ability to share with others. So for these documents, I went to share, I made the link open to the public, and you can pick viewer editor, just like all of the other Google products. And so next, just want to kind of show kind of the workflow that we're going to be going through. So we have some scripts here that are going to be in the Colab notebook. We're going to run those API requests like Jody talked about. And the requests are going to output TIFFs to the Google bucket here that we have set up for the next month for you to play around with. And then you can also pull back in from the cloud storage to be able to make maps or do further analysis. So some tips for the notebooks I saved today: make sure that you save as a copy in your drive so we're not all editing the same notebook. And then you're not going to want to make the scripts public because the API key, like Jody was talking before, you can have a lot of download requests, and we want to really keep it to this group working on that. So I'll go to the demos.
And while you're pulling that up, Kristen, you can write to your own Google bucket. So if folks have their own Google bucket, you can write to that so that you can egress, and you don't, and we don't get charged for the egress, you do. So.
And I'll point out in the script where you can do that.
Cool.
Awesome. So to orient you, here we have a Google Colab script up. We're connected to a runtime, so it has a green check mark here, and it tells us how much we have left for storage and whatnot. On the left here, I have table of contents. So when you're exploring this, I'm only going to look at a subset of these, but you can click and go to any of the sections and try them out. And then this little folder here, you can see I have the continental US shapefile along with some of our other exports that I've tested before here. So we'll be bringing the different data sets and we can see them in this folder. So to start out, you're going to want to import or install all of your packages. You press the little play button on the code section here. It gives me a nice check mark when it's done. I'm going to work through some of these. So I have installations that have to do with working with the data, putting it in data frames, some mapping packages here. So this is where you can edit out for your favorite packages moving forward. And then similarly to when we were working with the Swagger, we have our root URL. So geodata.dra.edu. So we're going to set that. The headers is going to be the authorization key. And so we'll run that. They're all very quick. And this is where you would change out your bucket. So we have AASC NIDIS here. And so we're going to run that. So that's kind of all of the prep to make a request setting up there. Next, we're going to move into requesting the raster section. So it has it here, but if I clicked on this, it would bring me back here also. So what I have set up here is it's reading in that shapefile from this folder, and then it's going to generate a box that's going to have bounds, and it's going to format those bounds in a way that the API call and the endpoint understands. And so there's documentation for each different endpoint on, is it looking for a bounding box, a polygon, coordinates, things like that. So it's going to bring that in and it's going to print out this bounding box so we know what we're pulling for. And now I'm going to go to the exploring land surface temperature. So I have two different API example calls in this section. One is for anomalies and one is for percentiles. So we've set out all of our background. Now we want to pick which endpoint out of that really long list matches what we're trying to look for. So here I'm looking for a raster because I want to make a map. I want to export it. And specifically, I want to look at anomalies. And so on that documentation page that Jody went over, I would search for this one. Then I'm going to make the file name. What do I want it to export as? And then set up those parameters. So specifically, I want to pull the MODIS Terra 8-day data set. The variable I want to look at is land surface temperature. And so all of these options are outlined within the documentation. So I don't have to guess. How do I format land surface temperature? It's going to tell us right there what variables are the option, and I can just copy and paste it. It's going to ask for temporal statistics, so mean, median, max, minimum. I picked mean. The calculation I want to do, so there's 3 different anomaly calculations. I picked anom. My start date is going to be January 1st of 2022. End date is July 31st, 2022. And then we have a start year and end year. So we're going to go 2000 to 2021. The bounding box is going to pull that box that I set up before. It's going to pull the bucket name and the file name right here as the export path. So these are all of the parameters that I'm looking to make that API request. I'm going to play that cell. And then I'm actually going to make the request here. So it's going to put all those pieces together, the root URL, the endpoint, all of the parameters, the key, and it's going to tell us what its status is. So you can see the little green arrow is going to run through, and then it's done. It's ready. And so what it's doing is it's making that request, and it's going to send that raster for that bounding box to the bucket I told it. And so you have some examples here we can see, because it can take some time for the whole US. So we can keep moving on with our example. So I just did the modus LST enum TIFF. So here it is. It'll tell you when it was created, its size, all of that. And so I'm going to just quickly do the same thing with percentiles. So the only difference in making the map is I'm using a different endpoint, and it's going to have a couple different parameters. Percentile step is a parameter. It just defaults. So I didn't include it here. And then we can run that also. And so it's going to do the same thing. And so now you have your raster and your Google Cloud Storage bucket. Say we want to generate and export a map. So I'm going to skip to this section first here. So what we're going to do is first get access to the Google Cloud Storage bucket. So what we pretty much have to do is run this little section. It's going to have your project ID, and it's going to have another pop-up that asks you to confirm, yes, this is my Gmail account that is associated. I want to connect to this. So after that, we're all ready to go. We're going to download the file from the Google Storage bucket. So I have my enum file name there, and I want to put it in my content folder, and I want to name it modus LST enum. So I'm going to run that. It should be pretty quick. It's telling you that it's copying it from the Google bucket. And then you're going to see it here, the modus LST enum TIFF. So if you already have it and you rerun it with the same name, it's going to just replace it. Next, I'm going to define the file path name. So I'm going to read it back into the Python script. I'm using some packages. And next, I'm going to look to generate my map. So I put a pretty simple one together. Again, you can use your favorite packages to stylize and add different features, but I'm going to generate the map. I'm going to add a color bar, set the title, and we have the output here. I'm also going to have the option to export, so we can see it's going to pop up. There's a non-PNG, which we can download directly to your computer from here. Same with the TIFF. And these files go away when your runtime goes away. So you'll want to make sure you download them when you do. And it's gonna show the map here. So this is between that January and July 31st over that time period. So it's the difference from average.
Yeah, you can really see the impact of the drought. Texas up through Oklahoma and Kansas. And then of course,
Definitely.
California, all the burn scars in California show up.
Definitely, and you can play with the coloration, but it's going to be the same thing you're seeing in the app here. Slight differences might just be the color scale, and you can tweak that. So we're going to do the same thing here with the percentile. So I'm going to copy that to my files there. I'm going to set a new file path, and I'm going to generate another map. And I will try to hurry because I do want to quickly do time series. But so for the same time period, this is the temperature percentile from distribution of past observations. It's going to look slightly different than the app because it's a continuous scale here, but you could tweak it to have the same colorations, but the trends are the same. Yeah, I'm going to quickly hop, and then if we have time for questions, I just wanted to point out that there's a time series notebook here. So we're going to do the same kind of workflow of installing our packages, setting up all of our variables to be able to make the API request. So I have single variable analysis and two variable analysis here. So we'll go to single variable. So our endpoint is going to look a little different. We're doing time series native points, and we set up these parameters. So I grabbed from the grid map drought the long-term blend from 1980 to 2022. I pulled coordinates so that those agricultural fields in California. I pulled a point from one of those that Justin showed earlier, and we're going to do a mean reducer. So I'll run that and make the request. And it's going to take a second. And you can kind of see I have the output still here. So once the request comes through, we're going to assign it to time series. We're going to turn it into a data frame that we can print. And you can see here it has date, the long-term blend values, and you can also export it as a CSV to these files here. And then you can click to download locally. This is where it really gets great. If you say have 100 areas, you can loop through them and create CSVs for all of the 100 areas with a loop there. So that's still running. But hopefully it'll be done soon. I don't think it'll let me do the next one without it, even though I had it.
Well, that's running, Kristen. There's a question from Christina in the web app. I think Justin just responded to it, but is there an automatic citation generator? So for example, when we build a product, a set of text is generated based on what data are used to construct the result.
Not super detailed. That's a good suggestion. And it's something that we're talking about doing is providing a metadata file. So when you download the data, metadata comes along with it. I mean, we do capture a lot of the stuff in the title, you know, the date range, if it's an anomaly or percentile, the data set, that sort of stuff. So the basics are there in the title, but a lot of the details of the metadata, like cell size and that sort of stuff, isn't.
Okay.
Thank you. So quickly, what we're going to do is we're going to filter out all non-available data. So that's the ones giving us the negative 9,999. We're going to format it so that it plots dates nicely along the end or on the x-axis. And then we're going to set the x values to date and then the y values or the long-term blend to value. And then we're going to generate this plot here, which looks just like this plot in the app. So yeah, we have our long-term blend on the left, our dates. You can obviously update the tick marks. You can have more of the years written out. Yeah, so I think I'm at time, but there's an example in there, kind of how Justin showed, having two variables plotted, the long-term and short-term blends.
Yeah, that's great. I think we don't quite have time for that, but that's really great. Well, we've gone through questions, but anybody have any now they want to raise their hand and ask, or any comments to share? People are busy playing away with it. Okay, well, any final words you guys want to share?
Just thank you so much, and please let us know how we can help. And you know, if you guys would like an API key, happy to pass some out. You know, we have this API key that's available for the next month. Please do keep that close to your chest, so to speak, in the sense that we don't want to get it out there too wide. But yeah, happy to work with everybody and do some one-on-ones. We do one-on-ones with people quite often, BLM specifically showing their teams how to use the API to batch download stuff. So This is an exciting time. It is a bit scary too, right? There's a lot of unknowns, and I captured some of those in my presentation at the very end. What are the costs? And the honest truth is you kind of don't know until you know, right? So that's what we're helping Steve at NOAA, drought.gov figure out, right? It's like, hey, if I do this every single day, what's it going to cost? Okay, well, let's figure it out, So happy to work with you through those things. And in my experience so far, it's like, wow, that's totally worth it. Like we aren't racking up, tens of thousands of dollars, right? It's totally worth it not to have to deal with this stuff on our own computers.
Right.
Yeah.
Well, you guys have clearly shown some really aha moments, and I'm sure there'll be more to come. And even the graph you pulled up, Justin, you said, oh boy, this gives some questions, right? That's a beautiful thing. That's a beautiful thing to get the data showing a certain way that then raises more questions and hopefully gives answers, but also then raises questions. So we really, NIDIS is so proud of you guys, and we really do hope this tool will be useful to you all state climatologists and others still on. Thanks, guys. And if you have questions, we are recording this. We'll get it out on the web and make sure you all have a link so you can work through it again. So thank you.
How do we ask questions? Is there contact information for particular categories of questions?
Going forward, yeah. What would you guys propose?
I'm just asking. Is there?
Yeah.
I noticed there wasn't or email addresses on the slide deck, so I don't know how to ask.
Yeah, that's a good point. I forgot to put my email on there. I'm putting it on there right now as we speak.
Okay, thank you.
Yep, and then we have questions, suggestions, a link on the Climate Engine app too. But yeah, feel free to reach out directly to me.
Yeah, just obviously everyone, you can imagine Justin's pretty damn busy, but
It's all good.
So
I can sync you up with the right folks.
Great. Okay. Thanks everybody for being with us, and thanks again to you Climate Engine whizzes. Really appreciated your time today.
Thank you.
Thank you.